So we got this example problem of kinematics that is also going to help us understand the meaning of each of the terms in the kinematic equations. So the problem says that there's a spaceship that's moving to the right at 50 meters per second when it turns on its reverse thrusters. So here we have that spaceship and with the reverse thrusters on, and those thrusters cause an acceleration of with a magnitude of 5.0 meters per second squared, which is pointing to the left. It keeps the thrusters on for 12 seconds, and we want to know how far is it from its starting position and in which direction is it traveling now. So I'm going to copy and paste. So whenever we do kinematics, we always have we're connecting 2 points in space and time. So we start here. So I'll call this my t. Here we are at t equals 0. So that's our starting point. So that's going to be our x naught, our initial position, and it's in space. There's no real reference point, so I might as well call my starting point 0. And then we're told that the initial velocity is it's moving to the right. So I can go ahead and draw that arrow, and that v naught is 50 meters per second. Now I can look at that arrow here and my arrow that I've drawn to define my positive direction, and I can say that velocity is positive. Okay, and so then, so I've got at my starting picture, I've got the time, the position, and the velocity. And so now I need to find those same things and write those down for the other one. So that's time is going to be 12 seconds later. The final position is what we're looking for. And then the final velocity, we also don't know. Now, in the first part of the question, it's not asking us this, but it's asking which direction it's moving. So I'm going to need to find the final velocity eventually. So sometimes there's things that we don't know and don't care about. In this case, both of these unknowns are things that I'm going to want to know. And then we have the last unknown or variable is the acceleration. Now that acceleration is the same throughout the whole problem. So I'll put it here, and we're told that it has a magnitude of 5.0 meters per second squared. But we're also told that it points to the left, and we can see that because the reverse thrusters are on, it would provide a force that points to the left, so that's going to be an acceleration that points to the left. So if I'm unsure whether that should be a positive or negative number, all I have to do is look at the arrow that I just drew. It points opposite to the way that my positive axis points. So that means that this is going to be a negative value. Okay, so the first question asks, what's the final position? So that tells me right away that I should check to make sure that I can use this equation. Right, so this is the equation for final displacement. And do I know everything here? Yes, I know the initial position, I know the initial velocity, I know the time, and I know the acceleration. So I can go ahead and calculate from here, and it's even already arranged with the unknown by itself. So, okay, so that starting position is 0 meters. So I can say, what's the meaning of this first term? It's where you started. Then I can say the initial velocity was 50 meters per second, and multiply that by 12 seconds. And then I have 1/2. So here the acceleration is negative 5 meters per second squared, and the time, again, is 12 seconds, and that needs to be squared for that term. So I can calculate each of these, right? So again, I've got 0 meters, I've got 50 times 12, that's going to be 600 meters. And then I'm going to get a negative number here. So that's going to be, what is that value? It's negative 0.5 times 5 meters per second squared times 12 squared. That gives me a value of negative 360 meters. So the meaning of these terms is I can say, well, that's the starting point. The 600 meters that I get from that term is the distance that I would have traveled at a constant velocity. So if the retro rockets had not been turned on, if I just stayed at that initial velocity, that's how far I would have gone. And then this final term, that's the, I'll put in quotes, extra distance due to the acceleration. Now, of course, because the acceleration is opposite to the direction that it was initially moving, this extra distance is actually a negative number. So it doesn't go as far as it would have if it hadn't turned on those reverse thrusters. Okay, so now I can calculate 600 minus 360 is 240 meters. Right, so the spaceship travels a distance of 240 meters in those 12 seconds. Now the other question is, which way is it going now? So which direction is it moving? That's a question about the final velocity. So the final velocity I can calculate using the velocity kinematic equation. And again, I know everything on the right-hand side. I know the initial velocity is 50 meters per second. I know the acceleration is a negative number, which is negative 5 meters per second squared, and the time is 12 seconds. So again, I can go ahead and calculate that number. So negative 5 times 12 is negative 60 meters per second. Right, so now what's the meaning of these terms? This is the starting velocity. And then this is how much it changed due to that acceleration. Okay, so I can see that when I take 50 and subtract 60, that means that my final velocity is going to be a negative number, negative 10 meters per second, which means now it's moving left. So it started out moving right, but the reverse thrusters were on long enough that it has now turned around and it's moving to the left.